Hi, Jaden. Okay, so in question number 15, it says, can a square whose area is 36, so you know each side of the square is 6, you need to figure out how long the diagonal is of that square. So if you use a squared plus b squared equals c squared, the Pythagorean theorem, 6 squared plus 6 squared equals c squared, to find that diagonal would be like your hypotenuse. You're going to get 36 plus 36, which is 72, equals c squared. So when you take the square root, you're going to get the square root of 72, which is 9 times 8. In simplest radical form, actually, 18 would be a big, not 18, 36, sorry, times 2. So it would be 6 radical 2 equals c. So that radius, 6 radical 2 is the length of that, that diagonal is about 6 radical 2. So 6 radical 2, when you multiply on your calculator, is about 8.485 is the length of that diagonal. So now if you can't compare it to a circle whose area is 54, right? Area equals pi r squared. So I'm telling you 54 is the area. So you're going to find out what's the approximate radius of that. So if you solve, you divide by pi. 54 divided by pi is about 17.19. That's the radius squared. So if you take the square root of that, which is, where is that? R is about 4.1459. So that radius is about 4.1459, which doubled to get the diameter. Doubled is about 8.2918. 2918. So the question is, will this circle fit inside of the square? Well, it'll only fit inside of the square if this diameter is shorter than the diagonal of the rectangle of the square. So 8.298 is shorter than 8.485. So therefore, yes, the circle, I'm sorry, sorry. The square, we want to know, does the square fit inside the circle? So only if 8.485 is smaller than 8.29. I was accidentally answering, does the circle fit inside the square? Does the square fit inside the circle? The answer is no. The square does not fit inside the circle because the diameter of the circle is shorter than the diagonal of the square. Okay, and I'll be going over this again tomorrow in class. All right, I hope this helps.